Alright, so in this first video of this unit, we're going to talk about the idea of simple harmonic motion. Now, even though we haven't mentioned this yet, we've actually already begun to explore some examples of simple harmonic motion in class, and we're actually going to take it a step further in this unit. So the idea of simple harmonic motion or harmonic motion is when something is vibrating or oscillating back and forth, and it's actually repeating its path in some sort of periodic motion, we say. So there is a repetition of the path. Right? So this is simple harmonic motion, and we've already looked at a lot of different examples of this. So one of the first examples that we looked at was circular motion. Okay, so as something moves in a circle, it is repeating its path. Okay, now another example that we looked at in the last unit would be a pendulum. Okay, when you have a pendulum, it's going to swing back and forth like this, right, and repeat its path. Also, we could have a mass on a spring, right? So we could hang it up off the ceiling, or we could also set it on its side. We looked at several instances with elastic potential energy in the last unit of a spring on its side, and if we were to extend it out, then it would start to oscillate back and forth like this in a repeating pattern. Okay. Likewise, if we were to take that mass and spring system and sort of hang it from the ceiling, right? Well, I guess we'll make it a spring, right? And I were to extend it out, then it would start to bounce up and down like this. And if there was no friction, it really would just kind of go on forever because there wouldn't be any loss of energy repeating its path up and down. Okay. Just as a reminder, remember that we have this idea in this oscillating of Hooke's law, which was the basically calculating force for a spring, which was that spring force, that should be spring force, is equal to kx, where this is the spring constant of the spring. And this is how far you move it, and this is then the force that it takes to move it that distance. Okay. Now, whenever you are repeating your path, it's called harmonic motion, but it's also called periodic motion, okay, or the repetition of the path. So if we recall, when we looked at circles, we actually looked at this idea of period. Okay, and so we're just going to go back and review the idea of period, but also the idea of frequency. Okay, so let's just review the definition. A period is the time it takes to, I guess, go one path, right? So if we're talking about a circle, it would be the time to do one time around the circle, one revolution. For a pendulum, it would be the time to swing up and back and then begin to repeat your path. For a mass on a spring, it would be the time for it to go from here, back, and then return to its original position. Okay, so these are all examples of periods. Okay, and the unit for period is in seconds because it's a time measurement, and quite often you see it written with the variable t for time. Right? Now, also when we deal with period, we deal with the opposite idea where you have time, or the inverse idea, where period is the time it takes to go one path, and then we also have the idea of frequency. So remember from circular motion we did like revolutions per second, which is the number of paths or cycles per second. And they're inverse of one another. So period is equal to 1 over the frequency, or frequency is equal to 1 over the period. So remember that frequency is 1/seconds, which we also give the name hertz. Okay, so a lot of this should be review, but it introduces you to the idea of simple harmonic motion. And from here, we're going to be moving on to the next form of simple harmonic motion, so our new form, and that's actually the example of a wave. So waves are simple harmonic motion because they repeat a cycle. And so if I show wave, you can see there's a repetition of the path. Okay, so in the next videos we'll get into waves and wave properties and then move on to sound waves and light waves.